Okay, so lesson 2 of this week, we're looking at indirect proportion, but the starter's on the screen, so please have a go at that. A bit of a reminder of all the different types of graphs that you may come across. So if you could just have a go at that, and then the next slide I will go over the answers, so you will probably want to pause it. Oops. Right, okay, so estimate a mean. So a mean from a frequency table. So we need the midpoint. Oh, I didn't put that. Hold on a moment. So that's better. We need the midpoint to start with. So midpoint of the group, we've got 5, 12.5. So basically add the two together and divide by 2. Be careful, they're all different. So that's 20. And that is going to be 65 divided by 2, which is, should know that, 32.5. Then you multiply the midpoint by the frequency. So we got 30, 12.5 times 5, which is 62.5. 8 times 20. Could really do that one in my head, but never mind. 160. And then 32.5 times 6, 195. Add all those together. So 195, add 160, 62.5, add 30. And once you've got your total, you then have to divide by the total number or in the frequency. So I need to add that column up as well. So we've got 6, add 5, do this on a calculator, how bad is that? Right, okay, so 25. So our estimated mean is going to be 447.5 divided by 25. Which gives us 17.9. Okay, which is a kind of sensible answer. 17.9 is kind of in the middle there. So our estimated mean is 17.9. Okay, frequency polygon. Now, frequency polygon is where you plot the points in the middle of the group. So let's actually set up our axes. 0, 10, 20, 30, 40, and frequency just going up the side, so we need to go as high as 8, 2, 4, 6, 8, and we're plotting in the middle of the group, so we've got 6 between 10 and 15, so in the middle there we need 5. Then between 15 and 25, which is there, so it's beyond 20, we need 8. And then between 25 and 40, halfway between 25 and 40 is going to be, well, we did it there, didn't we? 32 and a bit, 32 and a half, and we go to 6. And then you join them together with straight lines. Okay, so we're plotted in the middle of the group and joined them together with straight lines. Okay, cumulative frequency curve. Well, this is where you do a running total. So you've got 6, add 5, so we've got 11, add 8 is 19, add 6 is 25. Now I'm going to do exactly the same scale across the bottom here. I'm trying to make it a bit neater this time, perhaps. No, maybe not. Okay, so we've gone up in 10, so every little square is worth 5. We need to get up to 25. 2, 4, 6, 8, 10, 12, 13. Okay, that's helpful. Okay, I'm going to have 5, 10, 15, 20, 25. And now you plot at the end of the group. So 10, 6 is going to be about there. 15 and 11, so just above there. 15, 25, so I'm plotting at 25, and I need to go up to 19, 25, 19, which is there. And this is going to be a terrible graph. 6 and 40. No, sorry, 25. 40 and 25. So our cumulative frequency curve looks like that. Okay, probably a bit more of a Z in it than I've put there. But that's what your cumulative frequency curve would look like. And then a histogram. Well, a histogram, we need frequency density. Now, to get frequency density, we divide frequency by class width. Now, obviously, this was a topic you did on Thursday. So let's work out the frequency density. So we're going to do 6 divided by 10. Again, probably could have done that on my calculator. 0.6. This time it's only 5, so that's 1. Next one's 10. So 8 divided by 10. And this time we've got 15. 6 divided by 15. Which is 0.4. Right, okay, at least we've got some good numbers to plot. The same scale going across the bottom. So we've got 0, 10, 20, 30, 40. And we need to, I reckon we can do 0.2. So basically this is going to be, it's going to look like a bar graph, but with frequency density. Be the best way. 2, 4, 6, 8, and then 1. So now, between 0 and 10, we draw a bar that is 0.6. Okay, I'm sure you've done it a lot neater than I'm doing it. The next one, between 10 and 15, it goes up to 1. Okay, and then 15 to 25, we are at 0.8. And then the last one is at 0.4. Okay, I've noticed I've left off all my labels. So here you would need cumulative frequency on that one, and time in seconds across the bottom. I haven't really left myself enough room, but do please label your axes. Time in seconds, and that's frequency density, and here we've got frequency and time in seconds. Okay, so they are probably the 4 key skills that you need to do with your data handling. Appreciate a lot on one slide. Right, back to what we should be doing. Inverse proportionality. So we're going to be working with direct and indirect. So let's have a quick recap from yesterday. Y is directly proportional to x squared. If y is 10, x is 5, what is y when x is 15? Okay, so pause the video, have a go, see how you get on. Okay, so hopefully you've had some success. Look back at what you did yesterday. Y is equal to kx squared. Remember this constant of proportionality. Now I'm going to put my values in that I've got. So I'm going to square the 5. So k is actually equal to 10 over 25, which is 2/5 or 0.4. So now we've got our formula, y equals 0.4x squared, but we're told to work out y when x is 15. So y is equal to 0.4, which is what we got from substituting our values in here, times by 15 squared. Well, 15 squares is 225. Can't do that in my head. So 0.4 times 225. You should hopefully have got value of y being 90. Okay, so remember, constant of proportionality, work out the value. We could, perhaps we should have done, I did write out the formula there, and once you've got the formula you can work out x's and y's by working either way. So A and B are positive numbers, but A is inversely proportional to B. Now the only thing that makes it different, obviously it's inversely, so A is proportional to the inverse of B. So basically we've got it written, except now we've got 1 over, so when we put it into a equation, our constant of proportionality goes on the top as a numerator, and now we can work out the value of K using these values. So we've got 4 is equal to K over 36. So K is 4 lots of 36, 144. So our formula, A is equal to 144 divided by B. Okay, and now we can just work out our values of A and B if we had to. So if they gave us the value of A, we just have to do 144 divided by B, and vice versa. Okay, so fairly straightforward example. Let's have a go at this one then. So now y is inversely proportional to x squared. We've got a couple of values. Can we therefore work out that question mark? So pause the video, have a go, and then we'll have a look and see how you got on. So y is proportional to 1 over x squared. Again, we're going to form our formula. So we've got k, our constant of proportionality, over x squared. Put in the values we know. So we know y is 2. We know k, well we don't know k, we're about to find it out. And we need 25 because it's 5 squared. So k is 50. So actually our formula is y equals 50 over x squared. Now in the question we are told that x is 4. So y is equal to 50. You mustn't forget to square it. So 4 squared is 16, which is 50 divided by 16 is 3 1/8. I think, yes it is 3 1/8, or 3.125. Okay, so we're working through exactly the same method, just not forgetting the squares along the way. Okay, so let's have a look at 4 questions, all different. So first one, y is inversely proportional to x, p squared, a cubed, and the square root of v. Follow exactly the same pattern. I would work out the formula and then work out the missing numbers. Okay, so if you pause the video, have a go at those 4, and then we can see how we get on. Okay, I'm not quite sure I'm going to fit this on the slide, but we'll give it a go. So we have y is equal to k over x, just inversely proportional to. So we'll use these numbers. So we've got 5 is equal to k over 2. So actually k is 10. So our formula is going to be y equals 10 over x. Well, we've got x here. So actually 10 divided by 40 is a quarter. So that is going to be 0.25. Now, when we've got y, we can rearrange this because x is actually equal to 10 over y. So we can just swap those around. So 10 divided by 0.1, well 10 divided by 0.1 actually is 100. Okay, so that's the first one done. We're going to do exactly the same method with the next one, except now we've got q is inversely proportional to p squared. We're going to put our numbers in and put these numbers in. So we've got 4 is equal to k over 25 because it's 5 squared. So actually k is equal to 100. So we've got q is equal to 100 over p squared. So that's the formula we're going to be working with. So actually if p is 10, 100 divided by 10 squared is 100. that's going to be 1. Working back the other way, we can rearrange this. So we've got p squared is 100 over 100, because we know q is 100. So that is actually going to be the square root of, it's going to be p is equal to the plus or minus the square root of 1. Well, the square root of 1 is 1, so actually we could have 1 there, plus and minus 1 in there, if we're going to be really picky. But if you've just put 1, you'll be fine, certainly in that question. Right, next one. Now we've got a cubed. So what we need to do is set it up as we have. I am going to run out of room. So I put my numbers in and I get my formula that b is, so we've got 2 cubed is 8, 8 times 4, so actually it is 32 over a cubed. I've just substituted the numbers in, so 8 times 4 basically, times those two together. And if a is 1, oh that's handy, b must be 32. Even if we cube it. And now we need to do it the other way round. So a cubed is equal to 32 divided by 0.5. So a cubed, 32 divided by 0.5 is 64. So a is equal to the cube root of 64. And hopefully you're awake enough to realise that is 4. Okay. And then the final one, we've got w k over the square root of v. Substitute our numbers in. So we basically got 0.25 times the square root of 2304 is k. So I'm just going to do that on my calculator. W equals, I think it's 12 over the square root of v. So when v is 36, it's going to be 12 divided by 6, which is 2. And then when w is 0.5, we've got the square root of v is 12 divided by 0.5, which is 24, so v is equal to 24 squared. I don't know what 24 squared is. 576, there you go. Okay, so they're pretty much all you can actually get. And that question was very much like the one in your exam. Okay, you had to form the formula. Okay, so if you're doing these, you're already getting some extra marks on your exam. Should you ever have one, who knows? Right, so, oh, no, that's not what I wanted to do. What I need you to do now is, I wrote it down somewhere. Yes, on the worksheet from yesterday, I need you to do the workout. Let's find a page where I can write it down. So I need you to do workout 3, workout, oh no it isn't, sorry, workout 2, workout 4, and then there is the apply section as well. So there's 3 sections for you to do today, okay, from that worksheet. But that's what you need to do. These 2 are on indirect, and this one is on a mixture. Okay, so if you could do those, you would already spotted the next slides actually have the answers on. So once you've done your work, obviously check it with the answers. So workout 2, workout 4, and the apply. And once you've done that, can you please, some of you did really well today, write your review on Show My Homework so we can plan what we're going to do tomorrow. Okay, so that's proportion, and that's really all there is to it. So you guys have done really well to follow that. And probably what we'll do tomorrow is just a bit of practice on this. So we'll see how it goes. Okay, well, thank you and enjoy.